In March 2025, the U.S. Air Force quietly made one of the most significant fighter aircraft decisions in decades. Boeing was awarded a contract to build what is expected to become the first operational sixth-generation air superiority fighter, the F-47. This aircraft is not an upgrade of the F-22. It is not a modified F-35. It represents an entirely new design philosophy built around range, survivability, adaptability, and networked warfare. So what makes the F-47 different? Let's break down 5 major factors that could make it one of the most capable fighters ever built. One of the most discussed features of the F-47 is its projected combat radius, estimated to exceed 1,000 nautical miles. To understand why that matters, compare it to current 5th-generation fighters. F-22 combat radius, approximately 590 nautical miles. F-35A combat radius, approximately 670 nautical miles. That difference is not small. It reshapes geography. In the Indo-Pacific region, distance is strategy. Vast ocean spaces, separate operational areas from friendly air bases. Tanker aircraft are critical, but also vulnerable. An aircraft that can travel significantly farther without refueling reduces dependency on aerial tankers operating near contested airspace. That increases survivability. But range is not just about distance. It also means longer time on station, greater mission, flexibility, ability to choose engagement timing, reduced logistical strain. In air combat, endurance often determines advantage. 5th-generation stealth focused primarily on defeating radar in specific frequency bands. The F-47 is expected to go further, incorporating broadband stealth principles. That includes reduced radar cross-section across wider frequency ranges, enhanced infrared signature management, advanced radar absorbent materials, tailless or minimized vertical surface design. Infrared tracking systems are becoming more capable globally. Managing heat signature is increasingly as important as radar stealth. New ceramic-based materials reportedly under development are designed to tolerate high-temperature flight without degrading stealth performance. This matters because sustained high-speed flight generates extreme surface heating. Previous stealth coatings could lose effectiveness under thermal stress. Next-generation materials are being engineered specifically to avoid that limitation. The goal is not invisibility, but delayed detection and controlled engagement timing. Perhaps the most revolutionary shift is not aerodynamic, it's operational. The F-47 is designed to operate alongside Collaborative Combat Aircraft, CCA, autonomous or semi-autonomous drone wingmen. Instead of one fighter entering contested airspace alone, a single F-47 could coordinate multiple unmanned systems. These CCAs may perform roles such as forward sensor scouting, electronic warfare, decoy operations, air-to-air engagement, precision strike. This transforms the pilot's role. Rather than being just a fighter operator, the pilot becomes a mission commander. The manned aircraft maintains broader situational awareness, while unmanned platforms execute higher-risk tasks. Strategically, this shifts risk distribution. Operationally, it multiplies force projection, and economically, losing a drone is very different from losing a pilot. This networked model is expected to define 6th-generation warfare more than raw speed alone. The F-47 is expected to incorporate next-generation adaptive or variable cycle engine technology. Traditional jet engines balance efficiency and performance, but rarely optimize both. Variable cycle engines can adjust airflow paths internally depending on mission phase. In cruise mode, higher efficiency, reduced fuel burn, extended range. In combat mode, higher thrust output, increased acceleration, greater tactical maneuver, flexibility. This allows a single aircraft to serve long-range patrol roles and high-performance air combat without redesign. But the engine is only part of the adaptability story. Unlike earlier fighters, the F-47 is reportedly being designed with modular upgrade architecture. That includes swappable radar arrays, upgradable electronic warfare suites, open architecture avionics, future weapons integration compatibility. This ensures the aircraft entering service around 2029 is not frozen in 2029 technology. Instead, it becomes a platform designed for continuous evolution. One of the most unusual aspects of the F-47 program is that experimental demonstrators reportedly began flying years before the official production contract was awarded. That approach reduces traditional development risk. Historically, many fighter programs ran into cost overruns, delays, technology, readiness gaps, integration challenges. By flying X-plane prototypes and validating key technologies early, much of the uncertainty was reduced before committing to full production. This shifts the timeline dynamic. Instead of testing new systems after contract award, major technologies are reportedly already mature. That increases confidence in projected operational timelines. The F-47 is expected to exceed Mach 2, but modern air dominance is no longer about traditional dogfighting speed alone. Speed now supports rapid theater response, crisis repositioning, missile kinematic, advantage, disengagement flexibility. What matters more is information dominance. The aircraft is expected to function as a flying sensor fusion node, integrating data from satellites, other fighters, drones, ground systems, naval assets. The pilot sees a multi-domain battlefield picture, not just what's in front of the nose. That situational awareness advantage may matter more than maximum speed. The Air Force plans to acquire approximately 185 F-47 aircraft to replace the F-22 fleet on a near one-for-one basis. However, because each F-47 is designed to operate with multiple CCAs, the real operational force multiplier could be significantly larger. Instead of 185 standalone fighters, the force may effectively include 185 manned command aircraft, hundreds of collaborative unmanned platforms. That changes capacity without requiring equal increases in pilot training pipelines. The F-47 is not designed to simply outperform current fighters. It is designed to extend operational reach, reduce tanker vulnerability, integrate autonomous systems, adapt to evolving threats, maintain long-term air superiority. Air dominance is not static. It depends on sustained technological evolution. The F-47 appears structured not just as a fighter, but as an adaptable air dominance system. If fifth-generation aircraft focused on stealth and sensor fusion, sixth-generation platforms like the F-47 focus on range autonomy, network integration, survivability, continuous upgrade capability. The most important question is not whether it is faster, it's whether it changes how air warfare is conducted. And based on what we know so far, that appears to be exactly the goal